All right, class, let's continue this talk and find some derivatives of functions. Okay, see how we're going to do that. And see also maybe how can we find the instantaneous rate of change in a function or the slope of the tangent line to a function. Okay, so we'll start slowly. I am giving you some quadratic function, which by the way I kind of sort of graphed for you a little bit here. And we want to find the average rate of change from an x of 1 to an x of 3. So what happens if we move in this graph from an x of 1 to an x of 3? Yes. There's my secant line right here. Yes. And then let's see what happens to this graph of this function as we're moving only from 1 to 2. So this is going to be a different secant line. Okay. Not quite to scale, but it's pretty close. Okay, so an average rate of change is simply, all I have to do is find the change in the y values with respect to the change in the x values. Now, how do my x's change? Well, I'm asked to change the x's from what to what? From 1 to 3. So I'm going to subtract this x minus this x. Now, how do the y's change? I don't know. The y's are given by the function value. So all I have to do is throw in, find the y coordinate to an x of 3, find the y coordinate to an x of 1. Okay? So f of 3, that's 3 times 3 squared, that's going to be a 27. Yes? 27 minus f of 27 minus, here I'll write it down. 3 times 3 squared minus 3, that's f of 3, minus 3 times 1 squared minus 1, that's f of 1, right? All over 3 minus 1 is a 2, so 27 minus 3, that's a 24, minus 3 times 1 is 3 minus 2, that's a 2, all over 2, so this is going to be a what? 22 over 2, which is 11. Okay. Now, let's see, I have some room here. Find the slope going from 1 to 2 only. Okay, so this is what I will get. Again, it's going to be the change in y's with respect to change in x's. What do the x's change in between? They change from 1 to 2, so this is the difference in x's. F of 2 is the y coordinate to this, minus f of 1 is the y coordinate to this. So plugging in a 2, it will get us 3 times 4 is 12, 12 minus 2 is 10. Plug in a 1, 3 times 1 is 3, minus 1 is 2, plus, by the way, we had it here. So that's going to be an 8. So what we found out is that the slope of this line up here is 11. So for every one to the right, we're going 11 up. Whereas the slope of this secant line here is only an 8. Now, okay, clearly I'm going to try and figure out the slope of this tangent line, right, at 1 eventually. So what I want to do is not pick specifically one that's 2 units away, one that's 1 unit away, but one that's h units away. As I said, keep it as random as you can. So go from 1 to a little bit more than 1. And what we're going to do is to find the actual slope of that tangent line is let that h get close to 0. So find that limit. So to find the average rate of change between these two x's, yes, so all I have to do again is find the change in y over the change in x's, yes. By how much did my x's change? From a 1 plus h minus a 1, right? Same as here, we went from 3 down to 1, yes. Always subtract backwards. Not like you can't go this way, but that will get you more negative values, so you're more likely to mess up. So always start with a right hand point minus the left hand point. It just makes it easier. So what are the y values to this? Just as we said up above. I don't know, but what is f of 1 plus h? Yes, plug that in, right? We plugged in the 3 minus plug in the 1. Okay, so what is the bottom? The 1 minus 1 will go away, right? So we'll be left with an h. What is f of 1 plus h? Well, I don't know. Same as I plugged in the 3 value in here. Then I plugged in the 1 value in here. What do I have to plug in now? I have to plug in for x 1 plus h. Okay, so my formula says 3 times x, which is what? 1 plus h, square that, minus x, right? So 1 plus h. That's just f of 1 plus h. I plugged in 1 plus h into both these x's. Minus f of 1. Now what's f of 1? We actually found it already. But there it is. I write it one more time, because you guys are going to run into trouble with algebra. That's what it is. Okay, so I'm going to continue on my algebra. So sure enough, order of operations says 2 square this binomial, so 1 plus h times 1 plus h will get you this. And again, if you are not so sure why, take this aside and distribute, right? So you're going to get a 1 plus an h plus a second h, and h times h is h squared. So as you see, it's a 1 plus 2h plus h squared. So that's, again, squaring binomials. Yes. There's a formula for that. I suggest you guys review that, but that's a common mistake for students, to square binomials just by squaring the 1 and squaring the h, right? So squaring each one of the terms. As you see, that's not all, right? There's this middle term, okay, that also comes up. Minus, so as I said, that's a 3 minus 1, which is a 2. Really, the biggest mistakes for students to make would not be the calculus part, not derivatives, not integrals, whatever we learn, it will be the algebra, okay? So if you want to review anything, factoring, distributing, reducing, right, manipulating algebraic expressions would be a good idea. All right, enough talking. Let's get back to calculus. Distributing a negative, that's another common mistake. So combining like terms, this is what I'm going to get. I'm going to get a 5h plus 3h squared all over h. Okay, why? Because 3 minus 1 minus 2, that goes away. Okay, can we simplify this any further? Sure enough, look at that. There's an h greatest common factor at the top. That now gets reduced with this h at the bottom. Okay, so this is the average rate of change from 1 to any 1 plus a random h. Okay, so really, as you saw, what is the h distance between these two values? The h distance between these two values was a 2, yes? So if I were to actually plug this 2 in here, 5 plus 3 times 2, that's 11. Yes, that's why we got that. What is the h distance here between this first one and the second point that we found? The h distance between them is 1, right? If I were to plug in a 1 in here for h, I'm getting 5 plus 3, that's an 8, right? As you see, that's the value we got. So that's what I'm saying. We don't have to pick specific values. We could pick any random h, and that way, by just plugging in values for h, right? Oh, I went 2 units away. I went 1 unit away. I went 0.1 unit away. We can immediately find those slopes. Okay, now to find the instantaneous rate of change, that's the slope of the tangent line. So what did we say we're doing for that? We're letting this h get close to 0. Okay, so we already figured this out, right? The change in y's with respect to change in x's. all we're doing is now saying, okay, I don't want to go 2 units away. I don't want to go 1 unit away. I want to go almost 0 away, right, from this one. So since we already did the math on this, we already, in other words, did what? Reduced this expression, manipulated, and we know this whole ratio here came out to equal to 5 plus 3h. Now, can I find the limit of this? Yes, plugging in an h of 0, the answer is 5. So, in other words, what? The slope of the tangent line specifically at x equals to 1 is 5. Okay, so that's our instantaneous rate of change in this function. All right. Okay, so there it is. That's how we find an instantaneous rate of change. Okay, so let's continue, and this time go straight to finding the derivative of the following functions by using the limit definition. What do I mean, the limit definition? Well, I'll write it up again. What was the derivative? The derivative was the instantaneous rate of change in the function, right? Which is found by doing what? The slope of the tangent line. Yes? No, that's the slope of any secant line. If you want to find exactly the tangent line, we let this h distance get close to 0, right? So this, we said, is called the derivative of our function. So that's the limit definition, okay, which we had a few pages ago. Okay, so it says to find the derivative. Great. Here is the derivative notation. Okay. And how do I find the derivative? By finding the limit as h gets close to 0 of what? F of x plus h. Any random x, right? That says not the derivative at 1 specifically, which is what we found in the previous example, but at any random x point. So find me the slopes of the tangent lines at any random x point. Okay, I might be running out of ink. Okay, so let's leave that limit in there until we're ready to evaluate it. So what is f of x plus h? Here's my function right here. So what it says to find f of x plus h, yes, means to do what? In this function, wherever you see x, you write x plus h. So that's f of x plus h, right? So instead of x, I write x plus h. Right? If I want to find f of 5, that means what? Plug in 5 for x. If I want to find f of 2, means plug 2 in for x. If I want to find f of x plus h, plug in x plus h for x. Okay, minus f of x, that's easy. This is what f of x is, the function itself. Okay, there you go. I'm just copying it. Okay, so now all I'm going to do is manipulate this expression, simplify it just like we did on the previous page. So I'm going to distribute, and this one's easy. It's a 5x plus a 5h minus 6. Don't forget, many students will not put parentheses around this, which means you're not going to distribute that minus sign, and that's going to be sad because you're not going to get the right answer. Again, a little minus sign can throw it off. So your clue is that at the very end, you should always be able to reduce this h so you can find that limit. We cannot find a limit if I'm just to plug in a 0 for the bottom. I can't, right? But see how at the very end we're able to factor out this h? it got reduced, and then I was left with no h. So when I could plug in, find this limit, all I'm doing is substituting h with 0. But if the h is still in the denominator, you're not going to be able to substitute it with 0. You won't be able to find that limit. Okay, so that's your clue for knowing that you're doing the right thing. Now, so here, what can I reduce? The 5x gets reduced, the 6 gets reduced, right? Because we nicely properly distributed in the minus sign. That's a 5h over h. And now, can I reduce the h's? Sure enough, it's a common factor to top and bottom. So I'm left with the limit as h approaches 0 of the constant number 5, and there's no h to plug in. The answer is just the 5. Now, how come did we get the answer to be 5 no matter what? Of course, I cannot but tell you. What kind of a function is this? Well, it's a linear function, yes. Its slope is 5. So what happens to a linear function? Well, a linear function grows at a constant rate, right? It's not going to change, right? Any point I'm choosing, if I want to draw this tangent line, the tangent line is nothing but the line itself. So all these tangent lines have the same slope as the line itself, which is 5, yes? And that's, of course, the slope of this line, okay? So that's what's going to happen in a line, right? It's not slowly going up and down and up faster. It's not a curve. It's a line. It goes up at the same exact speed, right? So the slope doesn't change. All right. This is definitely going to be different. This function right here is a quadratic function, so its slopes will definitely, the slopes of the tangent lines will definitely depend on what x value we're at, or what point in the graph we're going to be at. So let's find that derivative. So the derivative of this function is the limit, by definition, that's the limit definition, of f of x plus h minus f of x all over h. That's what we're doing. So again, that's the calculus part. And now this is the algebra manipulation. So, and don't forget again, you're going to write this limit until you're ready to plug in the value of h. Okay. So what is f of x plus h? Okay, one more time. In here, instead of x, I write x plus h. Don't forget, it's got 2 terms. So this is your x squared minus 3x, right? Except for we substituted it with an x plus h. So this is f of x plus h. It says minus f of x. What's f of x? It's simply x squared minus 3x all over h. Okay. Don't forget the limit. And now it's algebra. X plus h quantity squared. Squaring again that binomial will get you the middle term. Don't forget about that. Distribute in the negative 3. Distribute in this minus. So now let's see. Can we reduce anything? X squared minus x squared, gone. Negative 3x plus 3x, gone. If you didn't distribute the minus sign, these would not go away and you'd be running into trouble. Okay. So this is the limit as h approaches 0 of what am I left with? 2xh plus h squared minus 3h. Now, what's important is for you to be able to reduce the h, and you only can do that if all the numerator terms also have an h in it, because you can't just divide 1 or 2 of those and leave the others alone, right? So when you reduce fractions, you reduce common factors. So h better be a common factor to that whole numerator. So in other words, it has to show up in each one of the terms. So sure enough, it does, right? Can we factor out this common h? Yes. Now it's a common factor. Now it gets to be reduced. And so now can I finally evaluate that limit? Remember in 1.1, we were definitely manipulating those ratios until we could finally plug in the x values that we were looking at. So now once it's gone, right, before I couldn't plug in a 0 because dividing by 0 is undefined. It's not giving me an answer. But now can I plug in the 0? Yes. So the answer is going to be 2x minus 3. So the derivative of this function is 2x minus 3. As I said, it's not going to be a constant value. Why? Because the derivative will very much depend on where you are on the graph, right? So again, this is a quadratic function, yes? The slopes of these tangent lines all have different values, right? Depends where, which x point, yes, in the graph am I stopping at. So this is why these derivatives depend on what x value I'm at, yes? So let's say I'm at an x of 2, yes? What's the slope of this tangent line? Well, at an x of 2, the slope of the tangent line is 2 times 2 minus 3, which is a 1. Okay, kind of looks like it, yes? So the slope of that tangent line looks like a 1, okay? All right, so let's see, one more. Let me make it green. Start looking Christmassy in here. Okay. So same thing. Find the derivative of this. Find the derivative of this function by using the limit definition. Yes. So here it is. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. I'm just keep writing it, so hopefully it will be drilled in. But again, we're going from an x plus h minus x, right? And plug in x plus h and x in the function values, right, for the y's. Okay. So this is a 1 over x squared. That's what this function looks like. So what do? Well, I'm going to plug in x plus h. This is f of, place of x, I write x plus h, minus f of x. Well, that's f of x right here, all over h. So how am I going to be able to reduce these h's and make them go away? It doesn't look very good, all right? Now, I'm going to tell you what we're going to do. We need to manipulate this expression so we can simplify it. One way is to subtract these numerators, right? Come up with one answer. Then once you have that answer, divide it by h. Or what we're going to do is use a trick, and this is going to be helpful for other problems. We're going to use a trick you've learned in intermediate algebra, maybe used in college algebra as well. This is what we would call a complex fraction. In other words, you have fractions within fractions. That's never a good idea. So what we do to eliminate these extra fraction lines is we multiply top and bottom of this fraction by the least common denominator of these little fractions you want to get rid of. So you're going to be multiplying both top and bottom of it by an x plus h squared times an x squared, which is the LCD for these two little fractions you want to get rid of. Okay, so equals to the limit as h approaches 0 of. Okay. Now, what's the advantage of this? Well, if I multiply these two terms by these factors, it means I need to distribute and multiply to each one of them. So when I multiply this fraction by these two factors, what's going to happen? The x plus h squared is going to go away. Yes, it's going to be crossing out this top one with this bottom one. And I'll be left with just x squared. when I multiply to the second fraction, what's going to happen? The x squared is there to go away, and you are left with x plus h quantity squared. The bottom has an x plus h squared, and an x squared. So don't distribute this. Don't worry about it. What we need to do, again, our goal is to be able to reduce this h. Yes, and so far it still doesn't look like I can. Okay, but I'm going to distribute that. So again, x plus h quantity squared, that's an x squared. That's a 2xh, and then h squared. Now, why did they all come with a minus? Because of the minus that was in front of them all. So I distributed that minus sign as well. Okay, so does anything reduce up there at the top? Sure enough, the x squares reduce. Great. These two terms that I have left, do they both have an h in them? Yes, they do, which is awesome because that means we can factor out that h finally. So if I factor out the h from these two terms that are left, what do I get? A negative 2x minus, factoring out an h from h squared leaves me with just an h. Okay, so here it is, common factor, right? This is all a product, so h is now a common factor, so it goes away. Okay, and to save some time and space, can I now finally plug in 0 for h? Yes, because I'm not going to get a 0 times anything, which always equals to 0. So I'm going to evaluate my limit, which means I'm dropping the limit sign. So I'm plugging in 0 for h, right? That's what it means to evaluate the limit. So when I plug in a 0 for h, I'm going to get just the negative 2x at the top. X plus 0, that's just an x squared times another x squared. Great. Can we reduce this a little bit more? Sure enough. These two multiply to an x to the fourth. And look at that, I can reduce one of these x's. So the ultimate answer is negative 2 over x to the third. Okay, so again, that was quite a bit of algebra, but nothing that you cannot handle. Okay, so I'm going to stop this video here because it's, again, getting quite long. We have just one more page of examples, and I'm going to continue that on the next video.